Question number 21. The ionization enthalpy values of three elements A, B and C are as follows in electron volts. Element A, I1 is 7.138, I2 is 15.03, I3 is 80.12 and I4 is 109.29. You can realize that I2 and I3 differ largely. So, this element is expected to have two valence electrons. Element B, I1 is 5.138, I2 is 47.29, I3 is 71.65 and I4 is 98.86. You can realize here that there is a huge difference between I1 and I2. So, this element is supposed to have only one valence electron. Then element C, 5.984 is I1, I2 is 18.823, I3 is 28.844 and I4 is 119.96. Here the difference, there is a large difference between I3 and I4. So, this element is supposed to have three valence electrons. Now, the question is which of the elements forms stable dipositive ion, and the correct answer is element A. Stable dipositive ion is formed by an element which can lose two electrons, and this is an element which is supposed to have two valence electrons, and the element with two valence electrons is A, because in this element there is a huge difference between I2 and I3. Answer is first option, element A. Question number 22. The electronic configuration of three elements A, B and C are neon 3s1, neon 3s2 and neon 3s2 3p1 respectively. The correct order of first ionization enthalpy. See, the first element is neon 3s1, this is element A. Element B is neon 3s2 and element C is neon 3s2 3p1. Out of these elements, the element with highest ionization enthalpy is not C, it is B, because of extra penetrating power of s orbital when compared to p. This element loses electron from s subshell, whereas this element loses electron from p subshell. S is more deeply penetrating than p. So, the correct answer is B greater than C greater than A. The option is second option. The reason why B is greater than C is extra penetrating power of S subshell when compared to P subshell. Question number 23. The first ionization enthalpies of carbon, nitrogen and oxygen respectively are carbon, nitrogen and oxygen. We know that the order is nitrogen greater than oxygen greater than carbon. The reason is nitrogen has stable half-filled configuration. It has a stable half-filled configuration, therefore its ionization enthalpy is greater than that of oxygen. So, on the basis of this, you can select the one where this particular order is given. So, the correct answer is fourth option. Carbon has 11.3, nitrogen has 14.5 and oxygen has a lesser value 13.6, lesser compared to nitrogen but greater than carbon. So, the correct answer is fourth option. Question number 24. Pauling scale of electronegativity values are measured based on option 1 bond length, option 2 bond angle, option 3 bond enthalpy and option 4 is bond order. See, Pauling's values of electronegativities are assigned on the basis of bond enthalpy values. So, the correct answer is third option, bond enthalpy. Question number 25. The ions with the same spin only magnetic moment in Bohr magneton are A ferric, B ferrous, C manganese, D Cr3+. Let's write the electronic configuration. See, in order to have same spin only magnetic moment, the ions should have same number of unpaired electrons, unpaired d electrons. If unpaired d electrons are same, then the magnetic moment will be same. Let's write the configuration. Ferric is 3d5, ferrous is 3d6, manganese is 3d5 and we have Cr3+, which is 3d3. This has 5 unpaired electrons, this has 4 unpaired electrons, this has 5 unpaired electrons and this has 3 unpaired electrons. So, it is ferric and manganese, which have same number of unpaired electrons, their spin only magnetic moment is expected to be same. So the correct answer is second option A, C. Question number 26. Isoelectronic pairs are A, ferric and manganese, B, cupric and cobalt 2 plus, C, cobalt 3 plus and Ni 2 plus, D, ferrous and cobalt 3 plus. Let's try to find out. Ferric, you get it by a loss of 3 electrons from Fe. Fe is 26, so it has 23 electrons. Manganese, you get it after loss of 2 electrons from Mn. Mn is atomic number 25, so after the loss of 2 electrons it will become 23 electrons. So ferric and manganese are isoelectronic. Let's look at this. Cu2 plus, this is one pair. Cu2 plus is 29 minus 2, that comes to 27. Then you have cobalt 2 plus. This is cobalt is 27. After the loss of 2 electrons, it becomes cobalt 2 plus, so it should be 25. So cobalt 2 plus and Cu2 plus are not isoelectronic, so B is ruled out. Then you have cobalt, not isoelectronic. This is isoelectronic. Cobalt 3 plus is 27 minus 3, it comes to 24. And then you have Ni2 plus. Ni2 plus is 28 minus 2, that comes to 26. So this is also not a case of isoelectronic ions. Then you have ferrous. Ferrous is 26 minus 2, that comes to 24. Cobalt 3 plus is 27 minus 3, again it comes to 24. This is a isoelectronic pair. So the correct answer is first option AD. Question number 27. Which of the following do not show diagonal relationship? A, lithium sodium, B, beryllium aluminum, C, lithium magnesium, and D, beryllium magnesium. Which of these pairs do not show diagonal relationship? Lithium, sodium, potassium, this is group 1A. Beryllium, magnesium, calcium, this is group 2A. Boron, aluminium, gallium, and so on, this is group 3A. Carbon, silicon, germanium, and so on. This is one diagonal pair, this is another diagonal pair, this is another. There are only 3 diagonal pairs in the periodic table. Therefore, the correct answer has to be fourth option AD. A is lithium sodium, they belong to the same group, so they are not diagonal. And then D, beryllium magnesium also belong to the same group, so they are not considered as diagonal pairs. The correct answer is fourth option AD. Question number 28. The assertion is thallium shows predominantly +3 oxidation state in its compounds than +1 state. Actually, thallium prefers +1 rather than +3. This statement is incorrect statement. Look at the reason. Thallium shows reluctance to get its 6s2 electron unpaired to take part in bond formation. This is true. This is called as inert pair effect. Assertion is not true, whereas reason, the statement 2 is correct statement. Question number 29. The assertion is both covalency and oxidation state of aluminum is same in AlClH2O taken 5 times 2 plus. AlClH2O taken 5 times 2 plus. Here, oxidation state of aluminum, because you have one chlorine here, so it comes to +3. This is oxidation state, whereas covalency is 6 because it is surrounded by 5 water molecules and chlorine covalency is 6. So they are not same. Covalency is the number of bonds formed by an atom of an element. Covalency is the number of bonds formed by an atom of an element. This is a true statement, and both covalency and oxidation state of aluminum is same in AlClH2O taken 5 times 2 plus is not a true statement. So the correct answer therefore is statement 1 is incorrect, statement 2 is correct statement. Question number 30. Here we have a match the following type of question. We in the list 1 we have periodic property, in the list 2 we have element. We have to match element with highest ionization enthalpy. Highest ionization enthalpy, the element with highest ionization enthalpy must be helium. It's a noble gas. It must be noble gas, and the element is helium, because down the group ionization energy decreases. So the topmost element will have highest value. Element with highest electron gain enthalpy, delta H Eg. This is chlorine. Chlorine has highest electron gain enthalpy. Element with highest oxidizing ability, highest oxidation potential. This is fluorine. Fluorine is the most powerful oxidizing agent. And then D, strongest reducing agent. Strongest reducing agent is lithium. Therefore, the correct answer is fourth option. A is matched with 5, that is helium. B is matched with 4. C is matched with 2, and D is matched with 1. The correct answer is fourth option. Question number 31. It's another match the following type of question. In the list 1 you have pairs of elements. In the list 2 the designation given to the pair. List 1 has lithium magnesium. Lithium magnesium. Lithium and magnesium, they belong to adjacent groups, so they can become a diagonal pair. Then the second pair is lithium sodium. They are alkali metals. They belong to the same group and alkali metals. Then this is A, this is B. C is boron thallium. Boron and thallium, they belong to third group, group 13 elements. They are group 13 elements. Then you have potassium, argon. These are anomalous pairs. That means argon has potassium is 39, argon is 18, Ar 40. So in the Mendeleev periodic table, argon should come before potassium because the arrangement is on the basis of atomic weight. So on the basis of atomic number, then argon comes before potassium. On the basis of atomic mass, potassium comes before argon. So this anomaly is there in their mass numbers. So they are treated as anomalous pairs. That's the reason why the correct answer has to be first option. This is how they are matched. Question number 32, another match the following type of question. In the list 1 you have nature of oxide, and in the list 2 you have oxides. Neutral oxide among them. Neutral oxide. See, non-metal oxides are either acidic or neutral, and in lower oxides are neutral and higher oxides are acidic. So the correct neutral oxide among the compounds in the list 2 is NO. NO is a lower oxide of N, and therefore it is neutral. Then basic oxide. Metal oxides are basic. So the metal oxide among the options is K2O. K2O is basic. K2O when dissolved in water will give potassium hydroxide, so it's a basic oxide. Then C is amphoteric oxide. Very popular amphoteric oxide is aluminum oxide. Al2O3 is amphoteric. It is insoluble in water and it reacts with both acids and bases. Then you have D, acidic oxide. Acidic oxide. Higher oxides of non-metals are acidic. So Cl2O7 among the list of compounds, Cl2O7 is acidic oxide because K2O dissolves in water, gives KOH. That's why it's a basic oxide. It is giving alkaline hydroxide. whereas Cl2O7 when dissolved in water it will give 2HClO4 perchloric acid. So it's an acidic oxide, it is producing oxyacid in water. Correct answer is therefore fourth option. Question number 33, another match the following type of question. In the list 1 you have number of unpaired electrons, in the list 2 you have ionic species, various ionic species. Let's try to match them. First you have copper Cu2 plus. This has 3d9 configuration, therefore number of unpaired electrons is 1 unpaired electron. Next, sodium. Two S2, 2p6. It has 0 unpaired electrons. Number 3 is manganese. Manganese is 3d5, so it has 5 unpaired electrons. Number 4 is Cr3 plus. Cr3 plus is 3d3, it has 3 unpaired electrons. Number 5 is ferrous. Ferrous is 3d6, therefore it has 4 unpaired electrons. So the correct matching therefore is third option, A3, B1, C4 and D5. Question number 34. Which of the following outer orbit electronic configuration represents elements with relatively large negative electron gain enthalpy? The first option is NS2, second option is NS2NP1, third option is NS2NP4 and fourth option is NS2NP5. You know, as the number of valence electrons increases, non-metallic nature increases, ability to lose electron decreases, rather ability to gain electron increases. So the correct answer is fourth option, NS2NP5. It is 1 electron short of octet configuration, so the element will have great tendency to pick up electron. Its electron gain enthalpy will be more negative because the process will be more exothermic. So the correct answer is fourth option. Question number 35. The strongest acidic oxide are generally formed by first option alkali metals, second option alkaline earth metals, third option noble gases, fourth option halogens. You know, alkali and alkaline earth metal oxides are basic, they dissolve in water to give alkaline hydroxides. So these two are ruled out. Noble gases do not form oxides generally, so the correct answer is halogens. Oxides of halogens, they are strongly acidic, when they are dissolved in water they give oxyacids. You can see Cl2O7 when dissolved in water will produce HClO4, a very powerful acid. So oxides of halogens are acidic, they dissolve in water to produce oxyacids. Noble gases generally do not form oxides. Alkali and alkaline earth metal oxides are basic, they give alkaline hydroxides. So the correct answer is fourth option. Question number 36. Strongest reducing agent among the following is option 1 lithium, option 2 sodium, option 3 potassium, option 4 cesium. Among them, lithium has the highest SOP, standard oxidation potential value. It's the most powerful reducing agent. The high reducing power of lithium is due to great hydration energy of Li+. Li+ due to its very small size, extremely small size, has a very high value of heat of hydration. That's the reason why its reducing ability is high. So the correct answer is first option, Li. Question number 37. The ion with equal or same magnetic moment in Bohr magnetons are A. Mn2 plus, B. Fe2 plus, C. Fe3 plus and D. Cr3 plus. Magnetic moment depends upon number of unpaired electrons. It is given by the formula root over n into n plus 2. The formula is mu equals to root over n into n plus 2 Bohr magneton. Here n represents number of unpaired electrons. N represents number of unpaired electrons. So species having same number of unpaired d electrons will have same magnetic moment. Let's look at this. Mn2 plus, it is 3d5, 5 unpaired electrons. The next is ferrous. Ferrous is 3d6. It has 4 unpaired electrons. Ferric is 3d5. It has 5 unpaired electrons. Then finally Cr3 plus. Cr3 plus is 3d3. It has 3 unpaired electrons. So Mn2 plus and ferric have same number of unpaired electrons. So the correct answer is second option, AC. Mn2 plus and ferric have same number of unpaired electrons, 5 unpaired electrons. Their magnetic moment will be same. So that's all regarding questions, some important questions on classification of elements and periodicity. Thank you. Thanks for listening.